My name is Dustin Campbell, and I'm here to show you what's new in C# 14. I apologize that it's just me, but my regular co-presenter, Matt Storkerson, is on vacation, and we'll hopefully see him soon. But yeah, so we're talking about what's new in C# 14. This talk will be the same as it has been in the past in the sense that we're going right to demo. Okay, it's just going to be code for the most part. I don't like looking at a lot of slides when I'm talking about language features. I want to use them, I want to see them. So first up, we're just going to do a couple of warm-ups of what's here. There are a couple of nice little features, and we'll start right here. Just kind of some appetizers, some tasters. So looking at this program, I've got a person class, and, it's typical, but it has a warning here because nullable reference types is telling me that this could possibly be a null reference, and that's bad, kind of annoying. So if I want to get rid of that, though, I've got to add a null check, right? So if person is not null, then then we'll hook up the event, and of course, then it just moves the warning around, right? So this is one of these features that's I appreciate it, but when I've got an assignment like this, where I've got code where I'm dotting into something and then I'm assigning it, we haven't really had a way to kind of get around that easily, to perform that null check. And part of that is because in C# 6, we chose not to make the question dot operator that's been around since then work for assignments. We just thought, hey, it'd be a little confusing at the time. But that was a long time ago. I mean, we're 8 releases past that. So yeah, with C# 14, you can use question dot in assignments like this. And the reason we thought it would be confusing is because when you do that, that means if it's null, then this entire block won't run. Nothing will happen here. And so you might end up with something where there's a side effect that isn't observed anymore, that doesn't occur. But that is, we just don't think that's as confusing as it used to be. So there you go. You can use question dot now for assignments. We call it the null-conditional assignment operator. The next feature I want to show, just again, it's a taster of just kind of small things that we do when, there's lots of things to kind of go clean up and make it a little easier. And that's this Lambda expression right here. An annoyance with Lambda expressions sometimes is that, I love simple Lambda parameters where I don't have to state the parameter type, but there are so many cases, and we've reduced a lot of them, but there's so many cases where I do have to state the parameter type. And one of those is when modifiers are used. And in this case, we have an out modifier on the success parameter. And in this release, you know what? Let's just not. In fact, there's a code fix to fix it for you. There's a suggestion and a fix. So often I see these, I usually don't see an out like this, but often you'll see a ref where it's there's some sort of, ref struct that's building something up and is being passed as a delegate, and you use it in a Lambda expression. So we're seeing that pattern more and more, and it felt like the right time to go and just say, let's just make this easier and clean this up. All right, next one. So this is a feature we've shown a number of times. This is field access in auto properties. Now, we've shown it a number of times because it's been a challenge to kind of get this out there and deployed in kind of the right way. But looking at this code, and I'll explain why that is. Looking at this code, we have really a C# 1.0 property. This is the same code you would have written a long time ago, right, in the C# 1.0 days. In C# 3, we introduced auto properties, and they're great because I don't have to declare a field. But there's this big cliff, right, with an auto property. In an auto property, if I do need to do something small, then in the setter for in this example, we're going to call an onNameChanged method. If I want to do that, now I have to kind of fall off this cliff and write the whole property and declare a field. And it's just kind of it's always felt kind of icky. So in this release, we're finally releasing the field access and auto properties feature. And here's what that looks like. So I'd really like to delete that field. Okay, so I can do that. And we can make this, a getter-only auto property. However, what do we do in the setter if I want to still do that? And actually, the warning from the compiler is telling me, yeah, I need to use field. Okay, there's a new keyword, that gives me access to that backing field. So here, I can set it. And now it's the same as it was before, essentially. You don't have the backing field if you were assigning it elsewhere in code, but if it's just only there to support this property, then you can switch over to the field property, to the field access. Now, the reason this was a long time coming and finally released is because it's a breaking change. You can have a field called field, and it's not weird, right? Databases famously have fields. And so this is a breaking change to have this keyword. And so what we're recommending in this case is that, you need to be able to disambiguate it. You need to either say, and Copilot was trying to help me out there and spoiling the fun. I can say this dot and disambiguate that this is a field access, just like I would in any other code. Or because this is a keyword, I can escape it with an @ symbol like I can with other keywords. Okay? And that is how it works. So, and of course I'm getting a warning here because now I'm talking to the field, but this is a getter only property. So it was talking to a different backing field. So I need to come in here and make sure I'm doing the same thing. There we go. So that's how this works. It's not too bad, and I really love getting rid of this sort of thing. And I think this has been a long time coming, and I'm glad it's here in C# 14. Now, one thing I've been using these for, I've been using them a lot lately. I just want to share these work great for like lazily initialized properties, right? So if I want to say do something like put out we'll say like an I-read-only list of person. Like maybe there's a collection of relatives here or something. And then I want to make that a getter-only property. I can do so with the field keyword, where I can say, oh, field keyword, yeah, okay. And then if it's null, and we use the null-conditional assignment operator, I can just assign it to an empty I-read-only list using a collection expression there. And now, and you can see that the tooltip tells me that, hey, relatives.field might be null here. And so we handle that and we initialize it with an empty list. So this is kind of a cool way to kind of do that sort of thing. And I've been using it a ton for that. So, all right. So that's your warm-up stuff. Let's get to kind of some meat and potatoes, some real nitty-gritty things. And let's talk about extension members. Extension members is something we've been talking about for a while, but it's also gone through some radically different designs. We started with it, honestly, as soon as extension methods were kind of, ready to go out before it was even released. I know that the C# language design team was already talking about, well, how do we do extension properties? And this is now like, many years ago. This was back in C# 3 that we put extension methods out there. And, extension methods were this nice little feature that was really in support of query expressions, link query expressions. And they became this kind of powerful, massive, popular feature on their own within, large swaths of ecosystem and libraries to kind of built upon extension methods. So we've been looking at this for a while because the requests keep coming in. How do we get extension properties? How do we get extension this and that and extension everything? And so in this release, we have kind of started that process and come up with a design that we think works. The reason it's taken so long is that it's been difficult to come up with a design that scales to other kinds of members, right? Methods are, not hard to do in one sense because they have all these extra features. Methods you can declare generic type parameters on them, and you have parameter lists. So in an extension method, I have a place to put this parameter right here, right? So this is an extension method. It kind of looks like Link's, first extension method. But that means that like other members need to have these features too, right? You need to be able to if I want to have an extension property, how do I declare an extension property with generic type parameters? Or where do I put this parameter because it doesn't have a parameter list? And so that's always been the problem. And so in this release, we are introducing a feature we call extension blocks. Now, extension blocks, I'm going to show what that looks like here. I'm going to copy this bit. This is the important bit of your extension method. And I'm going to copy it up here, and I'm going to take and say extension, and then I'm going to put it in braces. I'll remove this keyword, And there we go. That's an extension block. And what we're doing is we're saying we're taking the important bits that kind of make this method an extension method and moving them up to the top, okay? And so then I don't need the this parameter anymore because it's declared up in the extension block, okay? And in fact, I've got the parameter name source right there to be used down here. I don't need the generic type parameter because, again, it's declared in the extension block, all right? And then the last bit, and the reason there's an error on this source parameter is because it doesn't need to be static, right? And so what we've done now is we've taken essentially this, fancy static method, which is what an extension method kind of is. It's a, that we can call with instance syntax. And we have now changed the declarations so that the extra bits that are important, that kind of across the members, go up here. And then this is the signature that you would use in the instance syntax, okay? So like this method right here, we're calling first, and that's still calling this first right down here. And I can show that in IntelliSense, just like so. So if I go here, you'll see that, first shows right up. And it's got kind of a little funkier parameter info to let you know what's going on there, to let you know that this is a little bit different. And in fact, link is actually still here, it's link to objects, system.link. So, there are actually the overloads for link there, but here's ours. And that's pretty cool. Now, and we tried to make this so that it would always generate that same static method you would have written under the hood. This is inside a static class, and this is kind of a container that will contain different extension members. And under the hood, it's still generating static methods into that static class, right? The container is really, there may be some metadata, but it's not important from that language perspective of using C#. It's really, you can think of them as all just kind of being on the static class as they were before. So that means that when you need to disambiguate, and you can see we might need to disambiguate here in some cases because we have a link method and we have our so off of enumerable, we also have first, right, the link, and we also have the one off my-enumerable. So if we want to disambiguate, we call into the static class just like we would with a regular extension method. And you can see here, here's that static method, okay? And that's how you disambiguate. And so it's exactly like using an extension method before. We just, make you write a bunch more code instead. I'm joking, of course. That's not really true. It starts to build up and add and really start to reduce code that was there before. Let's try another one. We'll see. If I take select and I move that in here as well, okay, then I don't need the this parameter, and we can just do that. I don't need the t source generic type parameter. Okay, and it doesn't need to be static. Whoops, and I delete the wrong bit of code. There we go. And again, now you can see that the extension block is doing a lot of extra work for us here. We've got the t source declared at top. We've got the parameter. Now we've split the type parameters though. Select gets to declare t result. Select is a method that has two type parameters, one for t source and one for t result. But in the end, we still generate essentially the same thing that we would have generated before. And so you can see here that there's actually in parameter info, there is a select method with both generic type parameters that we kind of smoosh together. And so that's what that looks like. All right. But the whole point of this was to be able to add extension members, right? That this is a scalable syntax that we can add other members into. By lifting up those generic type parameters, lifting up, the this parameter, now they can be taken advantage of by other members. So making a property is easy. I just, turn this into a property. And we put get around there, and there we go. Now up top, that just reverted to calling the link method. But we don't have to. We can go, and there's our extension property. Okay, and extension properties, of course, they can have setters right here, and you could set that if you so desire. A little weird. We're getting a little weird here, but the thing about the setter is, and this is kind of reveals like kind of the edges of what an extension really is, and what it really is under the hood is that it's a static that is taking an instance of something and manipulating it, or being able to call methods or doing something with it. And so we don't really have a way in here to generate things that are like state on that instance that comes in. So once, the source that comes in here at the very top in the extension block where that's declared, when it comes into the property, we don't have a way to say put some field on that. And so instance fields are not supported, and probably will not be. That also means that, auto properties, field-backed auto properties, they won't work in extensions either. If you can write setters and you can store it on the side if you want, but that's something that isn't there today. Now, if I carry on with this, I want to talk about like the disambiguation. How do we disambiguate a property, right? Because we have first, but I've got a setter and a getter. And what we do for this for disambiguation is we actually generate and expose to you the methods that the compiler already would have generated for a property. Properties are actually sugar around a getter and a setter method, right? And so we expose those so that they can just be called as they would be. And so there's that. All right. Now, that's what we've kind of talked about in the past. I also want to talk about one other thing. Now, we've looked at instance extensions right now, but there's other stuff to look at. So let's shrink this down a bit. And on here, we also have just a regular static method, a range method. And this range method is useful, and it's useful in LINQ, where I can type enumerable.range. That's very useful. But it's not very discoverable, right? I need to know that in LINQ, there's this link to objects, there's this enumerable class that I can dot into, and there happens to be this helper method, this helper range method. And I can do the same thing here, right? I can call my enumerable.range because it's just a static method, right? But I'd really like to be able to call that in a more discoverable way. That's what's great about extension methods, extension properties now, is that I can press dot and get them on an instance and get them in IntelliSense, and I can discover them. Well, if I want to do that with a static method, it's also simple with an extension block. So suppose I want to say I want to dot into IEnumerable of int. Well, I could write an extension for IEnumerable of int without declaring a parameter. Okay? And again, it disambiguates because it's on my enumerable, but I can also type IEnumerable of int. And that works just as well now. All right, that's pretty cool. I could, let's see, that also means though, I wish though that like, if I want to write this for other types of IEnumerables, now I'm kind of stuck, right? I got to write a whole bunch of these. But we can declare generic type parameters. And so I could say, well, I've got a generic type parameter, let's let it take a t. And that'd be really nice if I could return that IEnumerable of t, and then, well, the starting value is going to have to be of type t, whatever that is. And down here, I see there's an error, and that's because I can't apply ++ to, operator to type t. But we, in .NET 7, we have this generic math thing. So if I constrain to I number of t, well, now it works. And that's pretty cool. So now IEnumerable of range works, but also IEnumerable of int.range works. And I could also say IEnumerable of long will also work. And that's, now part of that is because the 1 here actually, this is treated as an int32, long is an int64, and int32 fits inside of an int64. So this works okay. But if I were to change this to an unsigned int, well, now it doesn't work, right? And it's because this has that whole negative range that isn't part of an unsigned int. So in order to address that, I can come in here and we could just say, like, let's call it like range from 1. And we'll take off that first parameter, do a start here. Okay, and we'll call it up here, range from 1. There. And now it works fine. And now I can use it with anything. Okay, and it should work just fine. One last step though, this isn't as discoverable as I want. It's weird to type IEnumerable. Why do I have to type IEnumerable? That's not where I want it. I want to be able to say like int.range. And so we can do that. We can just get rid of this, do it like this. And there we go. Okay. All right. That's cool. I dig this. Let's go a little step further. Okay. We've looked at extension static extension methods. But another thing that's been requested a lot are operators, extension operators. In this release in C# 14, we've got them. So imagine we wanted to write an operator like, I wanted to write an operator in fact, for t here, where it's an I number. But I wanted to use the times operator. Say I wanted to treat range as this vector. Like if I wanted to treat an I-enumerable as a vector, and I wanted to apply a scalar across it, for example. So I could say, let's make an I-enumerable of t that is, well, let's make a static operator. Operator. I always mix up where these keywords go in operators. And we'll call it for times, and that's going to be on an I-enumerable of t, and we'll call that a vector. And then I'm going to pass in my scalar that I am simply going to do a select and then multiply my scalar across it. All right, so now let's go ahead and say loop through all this and write it to the console. And we should see, okay, this is just going to print out our 1 to 20. But now if I come in here and I say add a scalar, multiply it times 10, that calls into our generic operator, right? Here's another one. And this is also something else that's new in C# 14, which is compound assignment operators, which are intended for kind of types where it might be expensive to create a whole new type, and you want to kind of modify a type in place. And so I'm going to type this up very quickly, and we'll say another extension of t, and we're going to operate on an array where t is an I number of t. And then finally, I'm going to declare my compound assignment operator. And these are a little weird because they're not static like regular operator overloads. They're instance members. And they return void because you're updating the object in place instead of producing a brand new object like you would from a normal operator overload. So we're going to type this in. We're going to say operator, and I'm going to do a very similar operation. We're going to scale a vector. Okay, so let's go ahead and loop through the array. Oops. Typing a for loop has never taken so long. And let's go ahead and just scale each element. Oops. Scale. There we go. All right. And now I can take this and we could say, let's make a vector out of this. We'll call it, we'll just call toArray. Okay. And then I can call times equals 6. And that will call our compound assignment operator down there. Run this, and we'll see that now should be scaling up by 42. So that is kind of the nuts and bolts and big things in C# 14. I'm going to switch back to slides real quick. There's actually a lot that's new in C# 14, and a few things that we didn't look at. Partial events and constructors are, as we continue to fill out that partial story, especially for source generator scenarios. A nice little feature around unbound types in name of. But yeah, extension members, extension operators, even user-to-define compound assignment operators. This is cool stuff. C# 14, I hope, will be useful to you. If you want to stay kind of apprised of things and how to keep up in C#, there's the What's New in C# site over at learn.microsoft. This is a great place to find out, exactly what's new. And in every .NET preview, these get kind of updated over time as we're developing the language. And these kind of go in levels of kind of your engagement and how much you even want to engage in this. The language feature status, that's on Rosalind's GitHub page, GitHub repo. That's really a place where you can see kind of like an engineering schedule of how language features are being implemented and who's working on them and what the status is. And then finally, there's the C# language design repo. And that's a place where our design happens in the open. If you're really interested in that sort of thing, you can read the notes. You can see the disputes and the agreements and the votes and what we're doing next. Yeah, with that, thanks for checking this out.